Hello, everybody. This is a video for Module 6, and it's the first video of this week. As I mentioned in my previous video, I will be out of town from Wednesday this week to Monday next week. But I envision being able to post another video for this week. So if you have questions, please feel free to ask them. I had one question that was asked by Sam Kumar, and that was how many pages should the final report contain? So there is no set number of pages, but there are suggested pages, numbers of pages for each one of the sections. So for example, this one, use 1 to 2 pages to introduce your team, and then describe the client organization in 2 to 3 pages. So you have recommended pages for the various sections in the report. I don't recommend you go beyond the number that is listed there. See, this one is used 2 to 3 pages, so don't go beyond 3 pages. That would be my recommendation. And don't worry if you are at the bottom. So if you have, like, this one is recommended 2 to 3 pages. So if you have 2 pages, which could mean 1.5 pages, right? That would be equivalent to 2 pages. So 1.5 pages. If you can describe your variables in a way that is clear in 1.5 pages, that's fine. So use the instructions in each section to come up with the number of pages. Well, this one, for example, 1 to 2 pages. And at the end, you have a certain number of pages. It doesn't mean much to have more pages or fewer pages. If you have more pages but just text that it's not very informative, it doesn't help. I actually think being succinct is a good quality for a report like this. Okay, going back to the course, so, or the syllabus, so you have the commentary for Module 6 coming up by the end of the week. On Module 5, I noticed that there was one missing, one commentary missing, and one late. I also received the files, the revised files by Juan from his team. And so this is the Excel file, and this is the analysis file, the project file in WARPLS. And it's interesting now, more interesting and more reasonable than before. So we have average aid going up, graduation rate going up, and this is actually by far the strongest in standardized terms. So these numbers, since they are standardized, they are comparable to one another. So this is quite strong. This is interesting. I found it to be very interesting because you have hybrid, offline, which is only face-to-face, and online, and you see hybrid, and that's hybrid would be the number of students Students enrolled in some, but no, not all, distance education courses. So it does seem interesting to me that when you have hybrid, offline and online, all of these three variables included in the model, controlling for each other's effects, hybrid comes out on top, which I thought it was quite interesting, and online only at the bottom. Student to faculty ratio not affecting graduation rate. I found that to be interesting, that it doesn't have that much of an impact, but that doesn't mean that very high student to faculty ratios would be acceptable, because it's quite possible that the range of variation here is small. And let me show you how to check this. So if you go to data and viewer save correlations and descriptive statistics for indicators, you can see, and this may be useful for the other team as well, you can enrich your analysis by taking a look at the characteristics of your data, the raw data, and under this option, correlations and descriptive statistics for indicators. So when we look at student to faculty ratio here, we see that we have a mean of 14, so that's not much, and the standard deviation is 5, so that pretty much means that the vast majority of your data is between one standard deviation below the mean and one standard deviation above the mean. So it's most of the data is in the range of 10 and 20, so that's small. And if you look at the distribution, the histogram, you see an interesting distribution. I can tell that skewness is positive, which means that the data is bunched to the left, so it's shifted to the left. And kurtosis being this high means that the data is quite compressed in one area of the histogram. If that was not the case, if the data was fully normally distributed, these numbers here would both be close to 0. So when you click on view the histogram, then you see that the data is quite concentrated here around the 14 number. And that essentially means that there are no real many cases where you have very large student to faculty ratios. So they are at least the average numbers. So that is instructive. You may want to show this in your report, and that may be something that the client organization will find interesting and useful in the interpretation of the results. I would expect that if you had a wider distribution, so more like say around 50, then that particular variable, I would expect it to have a higher impact on graduation rate. Right now is non-significant or is barely significant. Again, if you distribute this a little bit better, you may not have numbers on top of each other, but you can always check them here directly on the path coefficients and the p-values. So here we have student to faculty ratio. It is statistically significant, and it is what you would expect. So it's negative, meaning the higher the student to faculty ratio, the lower is the graduation rate. And it is statistically significant, but is nowhere near in absolute terms at the level of influence of average age 8, average 8, salary of staff, right? That's an important one, but this is quite interesting. So having hybrid course seems to be important in terms of graduation rates. So having hybrid offerings for students, and this seems to be more important than having online and offline offerings. When having hybrid offerings is part of the analysis, right? So these three variables, they measure similar things, and they are probably somewhat correlated. So the multivariate analysis allows you to include them all in the analysis, and then their effects, which are these path coefficients, control for each other's effects, control for the other variables. So this is quite an interesting analysis. The other team has done an interesting analysis as well. All of both teams have done what I asked. So you have more than 300 rows of data. You have 7 variables or more in your models. So both teams have done what I asked. These comments that I'm making are just an attempt to make the analysis more interesting for the client organization. Of course, I don't know the client organization nor the data sets as well as the teams do. So this is more brainstorming where I'm giving you, but you could enrich your analysis a little bit by going to data and showing the distribution of the data in terms of the histograms, particularly in some cases where you would expect maybe a stronger effect, because student to faculty ratio, if you start having very large classes, you start having problems because you cannot really give a lot of attention to students when you have very large classes. And often when you have large classes, you have different ways of delivering those classes. So you may have a large class split into groups, and then you may have teaching assistants helping those groups and so on. But here, it is what you would expect, a ratio of around 14, not many higher than 10. So it's actually, on average, relatively low student to faculty ratios. In other words, when you have a small range of variation, the influence, which is measured by the path coefficient, is not very high compared to the influence of other variables. Now, you can also take a look at unstandardized graphs and then enrich your analysis, and this is something that is done in the textbook. So for average age, so let's take a look at the graph. For that, so average age, so let's take a look at the graph. So this is the focused graph. We can have a graph with data points, and we can have unstandardized scales. So this is the graph here. One thing you could have is an analysis using the focus graph, but with the path coefficients in them. So if I go to this option here, unstandardized scale, focused multivariate relationship with segments, unstandardized scale, so you have only one segment, and this is the unstandardized coefficient. It shows a 0 because it's the increment in graduation rates for one unit increase. For each 1 unit increase in average age, in dollars. So for each dollar you have, it shows 0 because it's a very small increment in terms of graduation rate increase. And so this is not very useful. And it's probably because this number, the number here is very large, so one increment would lead to a very small increment in graduation rate. So this is not particularly useful. Sometimes it's more useful when you have a larger number here. So if we had a smaller unit, right, of measurement, then, or a different scale, then we could have a number here that would be meaningful. The fact that 0 is just because the scale here is such that one increment here is one increment of $1. So this is why it's 0. It doesn't mean anything. In some cases it may be more meaningful. Okay, so what else? What other histograms could be useful to show average amount of federal state? Okay, let me see. Graduation rate. So yeah, we have graduation rate all over the place, right? But the majority being here around 50%, a little bit more than 50%. And that's probably graduation rate within a certain number of years. But interesting results from the other team as well. So that's what I had for today. I should be able to upload a video for the other week. It may not, now that I'm thinking about it, may not be possible because I need access to our server here, and I may not be able to do that from the road, so I may not be able to post a video for the end of this week. I'll try, but I think it would be difficult. So for today I will stop here. Good work, and thank you for watching.